Hello everyone, welcome back to Data Structures and Algorithm series. And in this episode, we will be exploring about Floyd Warshall's algorithm, the powerful method for computing the shortest path between all pairs of nodes in a weighted graph. So by the end of this video, you will understand about the definition of the Floyd Warshall algorithm, the concept of transitive closure, Warshall's algorithm, and its steps, applications, the code implementation. So let's get started. みなさん、こんにちは。データ構成とアルゴリズムシリーズへようこそ。今回のビデオでは、フロイド・ワーシャルアルゴリズムについて探求します。これは主につきグラフ内のすべてのノード間の最短経路を計算する強力な方法です。このビデオの終わりまでに次の内容を理解できるようになります。フロイド・ワーシャルアルゴリズムの定義、数一平の概念、ワーシャルのアルゴリズムのそのステップ、応用サンプルコードによる実装。それでは始めましょう。Let's first understand what is a transitive closure of a graph. The transitive closure of a graph represents whether there exists a path between every pair of nodes, regardless the path length. グラフの推移平方。推移平方について理解しましょう。グラフの推移平方とは、すべてのノードのペアの間に経路が存在するかどうかを表します。経路の長さには関係しません。What is Floyd-Warshall's algorithm? Floyd-Warshall's algorithm is a dynamic programming technique used to find the shortest path between all pairs of nodes in a graph. It is useful for weighted graphs, even those with negative weights. Even though it can handle negative weights, Floyd-Warshall's algorithm cannot detect or identify negative cycles. The algorithm updates a distance matrix to compute the shortest path between all pairs of nodes efficiently. Floyd Warshall アルゴリズムとは、フロイド・ワーシャルアルゴリズムはグラフ内のすべてのノード間の最短経路をまとめるために使用される動的計画法の手法です。このアルゴリズムは重み付きグラフに特に有用であり、この重みを持つグラフでも使用できますが、この重みに入るサイクルがある場合は適用できません。このアルゴリズムは行列を反復的に更新し、すべてのノード間の最短経路を効率よく計算します。Let's find the shortest path of this graph. Here we have a graph with multiple nodes and weighted edges representing the distance or the cost between them. So our goal is to determine the shortest path between these nodes. To begin, we represent our graph using a weight matrix. This metric lists the distances between each pair of nodes. If two nodes are directly connected, we see a numerical value. In Warshall's algorithm, absence of an edge is denoted by a pseudo-edge having an infinity weight. And in the absence of a loop, we can introduce a pseudo-loop having zero weight. In the case of multi-edges, edges with the higher weights are removed. Next, we apply the algorithm Floyd-Warshall to update the weight matrix step by step. We relax each and every column and row of the weight matrix so that we get the shortest path by refining the values based on the known distances. After several iterations, the algorithm coverages revealing the shortest path between the nodes. This allows us to efficiently navigate through the graph. And there you have it. The shortest path have been successfully computed. Applications of Floyd-Warshall algorithm. Shortest path in graphs. We can use Floyd-Warshall algorithm in network routing protocols to determine optimal paths, to help optimize the data flow in between networks, used in GPS navigations to compute shortest path routes, and used in AI path findings. Warshall algorithm の応用。ネットワーク内のデータフロー を最適化するのに役立ちます。GPS ナビゲーションで最短ルートを計算するために利用されます。AI の経路探索、パースファインディングに使用されます。Let's break down Java implementation step by step. So at the beginning of the code, we have import array class because we are using arrays when we are creating metrics, and then we define constant and initialize the graph. Here INF is used to represent no direct connection between two nodes in the graph. Implementing the Floyd-Warshall algorithm. First, we copy the input graph into a new matrix called, which will store the shortest distances between each node. Next, we are using a nested loop to compute the shortest path. Here, the first nested loop is used to intermediate nodes using path updates. I is determined to start the node and j is the destination node. The key update condition is when distant I and j equals to minimum of distant. This means if a shorter path exists via node k, update the current shortest path. Next, we are printing the output clearly. Here we print the shortest distance matrix neatly, and if there is no direct path, we print INF instead of a large number. The main method, here we define a graph as an adjacency matrix where graph I and j represent the weight of the edge from node I to node j. If there is no edge, we set it as INF. So let's run and see whether the code works. So this is the output where the matrix shows the shortest between all pairs of nodes. So in summarize, first we initialize the distance matrix, then we use 3 nested loops to update shortest path iteratively, and finally we print the shortest path matrix in a clear format. And that's it. So hope you now understand how to implement Floyd-Warshall in Java and interpret its output. Floyd-Warshall's algorithm is an efficient way to compute the shortest path between all pairs of nodes using dynamic programming. It has widespread application in networking, transportation, and optimization in problems. In this video, we explored its definitions, working steps, applications, and implementation in Java. So hope you enjoyed this video and thank you for watching. See you in next episode. Bye bye. 最後までご覧いただきありがとうございます。次のエピソードでお会いましょう。